Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. Back in 2019, I did a video on using the Nextion with the Arduino without using a library. But it was a little different kind of video. I was new to Nextion and I was trying to use it with AV equipment. The way I do it's just a little bit different. I'm going to go over the basic setup of the Nextion. On the main display I have 4 buttons, and they'll take you to where we're going to adjust a number or send it to the Arduino. We're going to send text, we're going to turn an LED on and off, and we're going to mess with a float, which is pretty much just the same as sending text or sending a number, but I get a lot of comments on sending floats. I'm going to have a button that will take us back to page 0. This button, just to start with, is going to send I was just going to increment this N0 value. If I wanted to adjust it, I would put an equal sign, and that would set it equal to 3. And you'll notice that there's no quotes around the 3. When you do a value, it's just the number. You don't put quotes around it. But for now, we're just going to increment this, just to make sure everything's working. On the text page, we're going to send text, T-E-X-T. So this button will take us back just like before. The send text will just put the word T-E-X-T up here in T0. And you'll notice I have the quotes on either side of it. And the important thing to remember about that is everything that the Arduino sends to the Nextion, if you're not using the library, has to be in the same format as what you use when you're in the Nextion itself. So if we're sending text, we have to also send the quotes. So we'll have to escape those, and I'll go over that when we get. Now for the radio button, or the LED, we're going to simulate it with a radio button and an off button. So either one of these will turn the LED on and off. We're going to have our back button just like normal. When we hit the off button though, and normally I use the release event, but we're going to do the press event. When I hit the off button, I'm going to change this R0 value based upon what the R0 value currently is. If it's 1, we're going to make it 0, and if it's 0, we're going to make it 1. And when we adjust that, we're also going to change the text on the B1. If we turn the LED off, we're going to change the text to off. If we turn the LED on, we're going to change it to on. Now when I send the value to the Arduino, we're going to have to build a string. So I have this variable down here called sendString. And we're going to use that to send the data to the Arduino. As I said, I included this float. It's pretty much the same as sending a value, and you'll see that when we get to it. But the float, all it does is it takes this number and it adds this decimal point. But really think of it as just a graphic. If I go to this VVS1 and change it to 1, now you can see it's 1 over. If I put 3 in there, it puts it 3 places over. So if you had an integer of 1, it would look like 0.001. It wouldn't be 1.00. So this is just an integer value, and that's just a placeholder. We're going to put it back to 2. Now this is just a progress bar, so it's just going to show you a value 0 down here up to 100 up here. And this is a slider, and it has a value of 0 to 100. And when we release it, we're going to have the value that this is set to moved over to this J0 and also in the X0. And it's going to be a value of 0 to 100. And then our back button is just like the other ones. But on this one, instead of 1 variable, we're going to have 2. Because we're going to have to take this H0 value and turn it into a string. I'm going to upload this, and I'm going to show you on the Nextion how it works. I have my Nextion display here with the same screen. We'll go to the number first. And then when we press this button, it just increments. That's all it should do. When I go back, I go to the text. When I hit it, it should just replace that with T-E-X-T. And you can see it does. Now the LED is different, and you'll notice I have it set off and the LED appears to be on. When I press it, it should sync up. So now you can see it's off, and now it's on, and now they are synced. And you can see I can press the top one too. Now we'll show you the float. Now the float, as I move this, you can see that it gets a value of 0 to 100, but it looks like it's 0.72 instead of 72. And that's what the X character does. All it does is moves that decimal point. So in this case, if you wanted to show it as 72, you'd have to multiply it by 100, and then you would get 72. Now we'll go back to the Nextion, and I'll show you how we send data from the Nextion to the Arduino. So I've commented out the increment value, because what we'll do is when we send a value to the Arduino, we're going to send a value back from the Arduino. And we don't want to get confused with having it increment the number and getting data from the Arduino. So what we do is we just print a command out the serial port. But if you're not going to use the library, the Arduino is going to have to know the command that you sent it. So every command that I send to it, I start with C:C. So in other words, I use the cheap controls with a colon in between it. And so when the Arduino sees a 3-character string, C:C, it knows that that's the beginning of some sort of a command. Then I use a 3-character string to denote the command. In this case, I'm using NUM for number. So I'm hitting C:C NUM, and that tells me that I'm getting command and that command name is NUM. And then the value follows that 3-character command, or after the 6th character, then I have the value. And the value can be any length, it doesn't matter. And it can be an integer or it can be text. It's going to come across as text, so the Arduino will have to turn it into an integer if it needs to be. But the nice part is you can send either one. And then I'm going to follow it with a question mark. So that way the Arduino will know if the command begins, and it's also going to look for that question mark at the end. Now if you were going to use a question mark in any of your data for your value, then you'd have to come up with a different ending delimiter. But for this case, we'll be okay with that question mark. Sometimes if it gets to be really complicated, I'll put C?C as my ending delimiter, and then I have to look for that. But for this case, just to keep it simple, I'm going to have a 1-character ending delimiter being a question mark. Now on the text page, I'm going to use txt as my command. So it'll be C:C, txt, and that'll be my beginning portion. And then the value that I'm sending it is text, and then I'm ending it with a question mark. And so you'll notice that that string is different. In the first one, I had 105, and in this one I'm having text. So the first one has 3 characters, this one has 4. And you'll see that that doesn't matter. The way I have it configured in the Arduino is you can send the value can be any length. Now on the LED page, this is where we get to where we have to build that string. So we initially set the send string equal to C:C LED, and we're going to use LED as our command. And then we're going to grab the text that's on B1, either on or off, and concatenate that to it. So it'll be C:C LED ON or OFF, and then we're going to concatenate a question mark onto the end of that, and then we're going to send that string out. Now we have to add the same commands to the light itself, or to the radio button. But it'll be identical. So when we send it, we want to send that same command up. Now on the float, we're going to use both these variables. So the first thing we'll do is we'll take that value, ho.value, and we'll store it in the temp variable text, and we use covx for that. And then after that, we'll build the string just like we did before. So we'll set the send string equal to C:C, but in this case our command is going to be FLT. And then we'll concatenate on that value that we just turned into a string, the temp.text, and then we'll add that question mark and we'll send it out. Now in this case I'm going to show you in debug how this works. We'll set this to string down here, and when I click this, you can see we get C:C num 105 question mark. And that will be the same thing repeated over and over and over. The text is going to be similar, only it's going to be txt and then the word text. And once again, it will be the same thing over and over. I'm going to clear this. Now the LED is going to have a change, but it's just going to be the on and off. So you can see I set it to off, because even though it's set off, it's not going to toggle because it toggled the LED portion. And now it goes to on and off. Now the reason that I included the float is it's still just sending an integer, but you're going to see we're going to get a lot of variables. And you can see that on release, so I didn't put the code in there on move, so I'll have to add that back in. But when I release it, it gives it the value, 30 and 82. So that value is going to change as we run through the program. I have to put the same code on the move. I'm going to compile this and upload it. And I'm going to do one more thing over here on this number page. We'll comment this out just for a minute here. For this number up here, you can select if you want it on the left, the center, or the right. But instead of using the words in coding, you would use a command to do that. So we'll leave it over on the right. But when I hit this button here, we're going to set it equal to 0. 0 is the left, 1 is the center, and 2 would be the right. And you can see it's over here on the right because that's where we set it in the editor. And when I click it, it moves over to the left. And I'm going to go ahead and set this back to the center. And the reason I showed you that is we're going to send this same command from the Arduino at some point, just to show you that you can send anything from the Arduino that is a command that works on the Nextion display itself. When I say anything, there's probably examples where it won't work. But in a lot of cases, if you can do it in the IDE here or in the Nextion by hitting a button, you can send that same command from the Arduino. Now in the Arduino, I have this basic setup that I always use at the beginning. And for the Nextion display, I have this end character set up, and that's just 3 characters of 0FF in hex. Every command that you send to the Nextion has to end in 0FF plus 0FF plus 0FF. So instead of having 3 lines, I just have that end character set up to be that. And then I just add that to the end. And then I have a string called DFD, which is data from display, and that's where I collect it from the serial port. And then I use an asynchronous delay, so I don't use the delay command. So it will run this asynchronous delay every, in this case, 50 milliseconds. But we're going to change this to second for now. So now it will run this delay every 1 second. And then I have a software serial because I'm using a nano. So I use the software serial and I use pins 2 and 3. And that's served me pretty well on the nano. If you're using a mega, I name it serial 2, which is a legitimate port on the mega. So you can just comment these 2 lines out and the code should work. And then I have to start both the serial ports because I'm going to use the one serial just for debugging for now. And I'm going to use serial 2 to talk to the Nextion as I defined up in that software serial. And then I'm going to use the internal LED to turn on and off from that switch on the Nextion. So I have to enable that, pin 13. And then I'm going to have another pin, pin 8. And I'm going to set that as a pull-up. And I'm going to use that then to send commands back from the Arduino to the Nextion. In the main loop itself, I have 3 functions that I use pretty much every single time. One is where I collect the data if there's serial 2 data available. I collect it and then I run this function, LCD input, and it's tied to a tab up here. And in this input, if there is characters available, it will read them and it will store it in that DFD. And it's going to look for 3 characters, C:C, and if the first 3 characters down here, if DFD length is greater than 3, and the first 3 characters are not C:C, it's going to reset that DFD back to empty. But if the first 3 characters are C:C, it's going to go down to this. And in this one, it's going to look for that question mark. So it's going to look at the whole length of the DFD, and if the last character is a question mark, then it knows it has a valid, complete command. and it's going to look within that command, and it's going to extract the command itself. It's going to get those 3-digit command. It's going to ignore the C:\C, and it's going to store that in the variable command. And then it's going to get the value, which would be after the 6th character, but not including the question mark, and it's going to store that in value. And then just for our reference, I'm going to print that. Now, if you're doing a lot of data very quickly, you won't want to do that. You'll want to comment this line out. But for testing, sometimes you'll put that in just to make sure you're getting a valid command. Now back over here on the main page, we're going to run this asynchronous delay. And we're going to run this function called initial async delay. And I call it initial, or INIT, because I may add additional asynchronous delays. And when I start it, I usually have it flashing that digital pin 13, just so I know that everything's working. And I can change that asynchronous delay length and make that light flash at a different rate. It's just kind of self-check at the beginning. In this case, I haven't commented it out because we're going to use that as the LED button. And then the final part of the main loop is the Nextion itself will send a command if there's an error state, and it will end with that end character. I don't know what it'll start with because it'll just fill up that DFD. And so what I do is I print the DFD, whatever the error message is, and then I also print error to let me know that I've printed an error. Now, if you'll notice on the serial 2 up here, the LCD input, if the first 3 characters are not C:\C, it's going to reset it anyway. So I'm really not going to get the error. But I could adjust this right here and make it longer. And then that way I would get some error strings, because I know that my value is going to be at least 1 character, and I'm going to have 6 characters with the C:\C in the command, and then the question mark. So that's 8. So I could make that 8 initially, or 7, and that way, if the error message was less than 7 characters, I would get it. But for now, we're going to leave it at 3. Now, just to start and show you that we can send commands to the Nextion, I'm going to add this command. So we're going to count that n0.value, and it's going to count up. But in this case, we're going to run this asynchronous delay every second. So when I upload this to the Arduino, it should start incrementing that LCD right away. So I'm going to go switch over to the camera and upload this, and you'll see how it works. Okay, I have it uploaded, but it's not counting. I think I forgot to flip this little switch. Yep, there it goes. So I've got this little board that allows me to adjust it between the programming port and the Arduino. So now we're counting up. Go back to the Arduino. And you can see here what we've done is we've sent the exact same command that we do in the Nextion. And just to show that it works with about any command, we're going to set that center. So we're going to move that number over to the right, because it'll be a 2. Because left is 0, center is 1, and right is a number 2. So that works good. So like I said, and what it's doing now is it's just sending it over and over and over. But it's sending the same command, so it's just going to keep it over here to the right. If I were to go back and come in, it should be in the middle for a second. And you could see it moved over again. We can even get kind of fancy, and what we'll do is from the Arduino, we're going to send a command to the Nextion, print S, and then it has to be contained within quotes. We're going to send the C:\C num 106 question mark. So we're going to send the command itself with the end characters up to the Nextion. The Nextion will do the command and will send that same value back down. It'll make better sense when I show it. I'll also pull up the serial monitor so you can see it on the Arduino side. And you can see we're sending out the num 106. So in the Arduino we had the command that's serial printing, and it breaks it up with a colon in the middle so we can see what's happening. Now the Arduino itself doesn't know what to do with any of this yet. We still have to put that in there. But you can see that it's sending it. We're going to stop this. and upload it again. And now when I press the button, you can see that it says num:105. And before, just to differentiate, I was sending 106. I'm going to clear this. We'll go to this text. And in this case, we're sending the command txt and the value text. Now on the LED, you can see we're toggling between on and off. Now on the float, we're going to send a lot of data. Because we're sending it as it's moving. So now we have to go into the Arduino and figure out how to interpret these commands. And we do that on the LCD input. Because here's where we're collecting it. We already have it where we collect the command and we collect the value. So now we have to just look for that command. So if the command is equal to NUM, what we're going to do is we're just going to send it back up to the Nextion. And we're going to say no.val, and we're going to make it equal to the value we collect. Now this is a very simple example because we're collecting 105, and so we're just going to change that value to 105. But you can see that it is fairly simple, and now we can just keep adding commands. So we'll just add one more command here that says if the command is equal to txt, then we're going to go ahead and change the text on t0.txt. But remember, it has to be identical. And so when we're changing the text, we have to have the quotes around the text. In this case, the values come in as string, so I'm casting them as string. I really didn't need to do that. You could leave this portion off. But sometimes I'll have an integer or toInt command to change it back and forth. So I like to be clear in what I'm doing. So we'll have the text of t0.txt equal, and then the backslash quote will make sure a quote is inserted. And then we're going to concatenate the value to it. But then we have to concatenate another quote to it. And then we have to add the end characters. And what I'll do at the end here is I'll pull it up in the debug mode so you can see these characters being passed through. Now for the command LED, we're going to use what's called a ternary operator. So if the value is equal to on, and it's true, then we're going to set that LED to high, the onboard LED. But if the value is off, or actually any value but on, then we're going to set it to low. We're going to upload this, and I'll show it working at this point, because then we're going to add an external switch to turn on and off the light. So now if we tap this button, it will send the command back to the display to change that 0 to a 105. Now we'll go back and we'll do the text. And we sent the text. And now we'll go back to the LED. Now this one should change the LED on the Nano. And you can see it's on, and now it's off. But I also have this button right here. And I want to be able to turn it off if it's on, like an emergency stop switch, by pressing that button. And that's why on this setup I have pin 8 set up as a pull-up. So anytime I take it low, I'll not only want it to change the actual LED, the physical one on the Arduino, but I'll want it to change it on the Nextion also. So we'll go over to the async delay. And if that digital read pin 8, we're going to check it every second, so we'll have to hold it. If it is low, then we're going to serial print line output low, just as an indication on our serial monitor. And then we're going to digitally write 13, we're going to take the pin low, and then we're going to update both b1.text to off, and we're going to set that R0 value to 0, which will make it look like it's off. So now I'll turn it on. And you see we get that LED on. And then I'll take this button and I'll hold it. and it set the output to low, and it sent the commands to make it look like it's off. And now I can turn it back on. So we can in the async delay, we can affect an action, and we can also affect it over here. Now we'll go over onto that float. And that's why we have this integer float value set up, because we'll want to refer to it. If the float value doesn't actually change, I don't want to continually be flooding the serial port with data. So I have this global variable called float value. We're going to do something else in this async delay. So every second, we're going to check the value. We're going to get the value of a potentiometer that I have plugged into A0. And then we're going to set that temp value. And it's going to take that value that I collected off the potentiometer, because the value coming in is going to be 0 to 1024. So it's going to take that value and divide it by 1024. Then it's going to multiply it times 500. So it's going to get me a value between 0 and 500. But the reason I multiply it by 500 instead of 5 is on the display, remember, I have that set up as a float. So I've got that decimal point. So multiplying by 500 will give me that decimal point. So the integer will be 500, but on the Nextion display it'll look like 5 point something. And the only time I want to do this, though, is if the temp value isn't equal to the float value. The first time through it won't, because the float value is 0. But then in this line I set them equal. So if the value doesn't change, it's not going to update the display. But if the value is changed, we're going to change that x0 val. And then we're also going to change that progress value, that bar that goes up and down, that J0. We're going to do the same thing. We're going to get the ratio of the pot value divided by 1024. But in this case, instead of 500, we're going to multiply it by 100, because that'll give us a number between 1 and 100. We also have to end the end character on both of those. So let's check this out and see how it looks. So I still should be able to move this just like before, and the two values follow it. But if I go to this potentiometer, I should be able to change it, and you can see that it also adjusts. Now the asynchronous delay is only every second, so it doesn't keep up very well. But it does work, and you can see that I'm adjusting those values separate from that bar that I can adjust with my finger. And if I go back and I adjust this again, it'll change those back to the other values. So now we'll go back to this asynchronous delay on this page 1 here, or the main page. We're going to set this to 50. So now that I have it uploaded, we'll make sure it still functions. And it does. And now when I spin this potentiometer, it should update faster. And you can see that it does. And it's giving us a voltage readout. And what we did in the Nextion is we set up a format so that we're always sending something that the Arduino can interpret. And we started with that C:C, which tells the Arduino that it is a legitimate command from the Nextion. And then we follow it with 3 characters that tell us the command. And you can make that 4 or 5 characters, but it's better if it's always the same number of characters for the command. It just makes it cleaner on the Arduino side. And then after that, then we have the value. And the value can be any size, which that's kind of nice with the way we have it set up in the Arduino. And you can see on the text, I still do the C:C with the TXT. On the LED, I send 2 different lengths, off and on, a 3-character and a 2-character. And then in the float, I send it. I don't actually really do anything with it on the Nextion or on the Arduino, but I send it just to show you that that's how you would do it. And then in the Arduino, if you're sending a value, you don't need to put quotes around it, because you don't put quotes around it on the Nextion when you type in the command. But when you're sending text, you have to escape character that quote, so you make sure to include the quote in the string. I'm going to show you this in debug so you can see the difference, and you can see that this backslash doesn't come through. And what I have is I have this little board here, and I can unplug it. And then I'm taking one of these USB devices and I'm plugging it directly into the laptop, and I'm taking the output out of the Arduino on pins 2 and 3, the serial 2, and connecting it directly to the display. So now I'll go to the Nextion and I'll run it in debug. Before you can do anything on it, you have to go down here, and then you have to select the COM port that you want to use, which in this case I don't have it plugged in yet because I know that COM port 11 is the Arduino. And then since I just plugged in, I'll have to stop this. And then I had to go back in. And now you see I have 10 and 11. So I know it's 10. And then I'll hit start. And now we're connected to the Arduino. So I've stretched this a little bit to make it look a little bit better, and hopefully we can see what's going on down here. I'm going to set these both to string. H is hex, S is string. We'll go to number, and now when I hit this, you should see it be sent here to the Arduino, and the Arduino should reply here, unless I have my transmit receive backwards. So I sent that into the Arduino, and if I look at my COM port on my Arduino, I'm not getting anything. So I might have the pairs backwards. So it would be these two wires here. I may have them connected reversed. So now we'll go back. Oh, and you can see I'm getting data now. So let's clear this. I'm getting data from that potentiometer. So it must be a little bit flaky. And that's okay. But what I'll do now is I'll go back to here. We'll go to that async delay, and we're going to comment these out so we don't get that right now. This is that X0 and J0. I'm going to upload it. X0 and J0 right here. I'm going to clear these. Now we'll try it again. So I sent that, and then I replied. It's funny that the receive almost came up first, but that isn't the way that it happened. It gets sent first, and then it receives back. So let's go back now, and we'll go to the text. And you can see that the Y's are how the Nextion interprets that FF. And you can see that the quotes are in there. But if I go up to this one above, the value, there's no quotes around that 105. And you'll also notice that the backslashes aren't there. And if you needed a backslash, you'd have to put a double backslash. Let's go back and let's look at the LED. Now this shouldn't send anything back. All we're doing is sending something to the Arduino to turn the LED on and off. But if I hit that button, you can see we got a bunch of offs. But you can also see that we had to escape sequence it with the backslash around, because since it was text. But the R value, which we set to 0, we didn't have to put that around it. So sometimes what you're going to want to do is you're going to have two serial ports on your laptop or your computer. And in my case, it's 10 and 11 right now. And then you can have the debug window going to a secondary serial port on your Arduino. Like in my case, I'm using serial 2 on pins 2 and 3 of the Nano. And then you have the regular Arduino port. And then you can see this activity down here on this debug screen. And that's really helpful because it lets you know what it is you're writing to. And even if you're sending the wrong command, we'll go back to the Arduino, where we send this right here, this B1 text off. And so what I'm going to do is I'm going to get rid of these quotes. So now we're sending b1.text equal OFF. That's all we're sending. And without those extra quotes, it's not going to work. So you'll see we can still hit the button and we're still sending the on and we're sending the off. But let's turn it on, and I'm going to hold the button and you'll see the commands come through. And a lot of commands came through, 336, because remember we changed that async delay to be every 50 milliseconds, so they were coming through fast. But you can see that this text didn't change. The LED down here did, or the radio button that we have simulating the LED changed, but that text did not. And you can see because there's no quotes around it. And it just won't work that way. And then over here, we got some error messages. And this, if you look into it a little bit, and I might do a video on error messages at some point, but if you get an error message, then that means you're sending some sort of command wrong or something. And you can see in here it says parsed an invalid variable. So instead of looking at this as a command, it's saying that OFF is a variable. So it just got confused on that because it's not a legitimate command. But if we go back to this, and we put those escape sequences back in there and add the quotes again, now we're able to turn it on and off just like before, but let's turn it back on. I'll hit that button and you can see that it went to off and that went off, and we got no error messages over here. So when you see these error messages, that means something's wrong over here. And this gives you a good indication, whereas you can't really see this on the display itself. So I hope this video helps, and I hope that it's a better video than my initial one. If you have any questions, put them down below. I'll do the best I can to answer them, and I'll do a follow-up video if I need. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.